So my presentation is going to be very different from everything you've heard so far today. I'm going to give you some of the lessons learned in my career and give it, hopefully what you'll take away is an appreciation for management's perspective. I just heard the last presenter talk about how management is always saying, "Are you done yet?" I've been on the other side, though, too. So first I'm going to start by just telling you a little bit about myself. Up until 2 years ago, I worked for Johns Hopkins Applied Physics Laboratory. And in my early space career, I worked on deep space missions and then moved into people management. And I was overseeing all of the flight software, ground software, and science analyst software engineers. And during that period of time, I learned a great deal. And I'm going to talk mostly about that period of time today. Almost 2 years ago, I jumped ship and went to work for aerospace. And at aerospace, our job is a little different. It's completely focused on mission assurance. And in that role, I've been working primarily on ground systems. And so I want to tell you a little bit about what I've learned from there and the real appreciation I have of flight software now. And recently I came back to flight software, and it's such a breath of fresh air. It's much better. Okay. So I'm going to talk about things you probably already know. Why is it difficult to develop flight software? You all could tell me that, and we're probably being in sync there. Then I'm going to tell you why it's difficult to manage that development. And then the lessons I learned to help me manage those development efforts, and also just general lessons I learned about flight software development. And then give you a conclusion. And the conclusion might not, I don't think it's controversial. We'll see. So flight software is embedded. You can't see it. You don't have a user interface. It's basically transparent. You have to build instrumentation so that you can debug it. Although I was really happy to hear about the CubeSat application with the processor that had the debugger built in and you could single step through instructions. I wish I had had that. That would have been nice. Flight software typically has hard real-time constraints. You have to meet performance requirements. If it's not done on time, it's not right. And that can be an issue, and that can make it very complicated. Flight software is mission critical. If it fails, you may lose your mission. So you guys are the rock stars in the software world, as far as I'm concerned. You have to make sure it works. And then, as I mentioned before, invisible and embedded kind of go hand in hand. You can't really see it. The other things that make it difficult are schedule constraints, and constraints that are brought upon flight software because you interface with so many other subsystems. Functioning flight software is often needed early in INT. You have to have flight software in order to test the electrical systems, subsystems, and the ground system. But you're caught between a rock and a hard place because the flight software has all these interfaces to the hardware, and the hardware engineers may be still designing those interfaces and changing them on you, and that changes your requirements. And so your requirements don't get solidified until later. That results in sometimes flight software will change right up until launch. And I will tell you, as a manager, that's the scariest thing. I did not want to see flight software changing within months of launch. And the other scary thing for a manager are the uploads of flight software after launch. Those kept me awake at night. Most of this I've mentioned already. The flight software controls and monitors all the hardware subsystems, electrical, power, guidance and control, navigation, and all of the instruments. Can I tell you a story about my first experience with instrument software engineers? I came from a world where when you defined an interface between two subsystems, you didn't change it without bringing all the parties together, talking about it, and agreeing on an approach. And then I met instrument software engineers. I hope I don't, are any of them here today? And we agreed to our interface. A month later, I check in with them. They've completely changed their requirements for what they needed in their instrument, and never told me. It was just by luck that I happened to ask them. And then, a month or so later, they changed it again. And they kept changing it all along the way. So that was a lesson learned for me, is that it's not because they don't want it to be solidified. It's because when you're building a science instrument, you're basically working in the area of discovery. How can we get the most science from the hardware and software in that instrument? And so, they have to push the boundaries, and that results in an unstable interface. But it makes your job hard. Oftentimes, and that example illustrates it, the subsystems and science instruments are developed independently of the flight software. And unless you have lots of interaction, things can go awry. As flight software engineers, you have to understand all of the subsystems with which your software is going to interact. So you should definitely be participating in trade studies. I'll tell you another story. I worked on the first space mission I worked on. We had 3 processors on board. One was for an interface to the guidance and control sensors and actuators. One was for processing command and telemetry, and the other was actually executing the guidance and control algorithms. Well, I went on vacation for a week, and I came back, and the hardware engineer had decided we'd only get 2 processors. We were already down the path of designing the software. We were counting on reuse from a prior mission because it was this particular mission was cost and schedule constrained, so we needed a leg up to help us get there. I was horrified. So I quickly wrote a paper with a trade study of why this wasn't a good idea, and the program manager heard me, and she reverted to the previous architecture, the before vacation architecture. You should be involved in risk assessments. Now I have a bad story. This was the saddest moment of my career. I worked on a mission called Contour. And during the risk management process, I raised the issue of what if something bad happens once we fire the solid rocket motor? And everybody said, can't happen. All the hardware guys, can't happen. The software worked flawlessly. When we fired the solid rocket motor, there was an issue with the thermal, the flow back onto the spacecraft, and we lost the spacecraft. I know that each of you can appreciate how bad that feels. That is just an awful feeling. It's like somebody died. You spend 4 or 5 years of your life completely dedicated to something and you lose it. That's awful. Well, make sure you're involved in risk assessments and make sure you're heard, because bad things can happen. The things that can never happen always do. Murphy's Law. You have to wait until all the other subsystems are finalized before you can finalize your flight software requirements. You frequently have to wait for your hardware engineer colleagues to build you specialized hardware to test your software. You may need breadboards from them. You may need a special test environment. Right before I left APL, one of the system engineers came up to me and he said, "You know what, Robyn? You have a real legacy here. You created the software mafia." Because I trained my engineers to be aware of all the hardware issues, all the hardware changes that were coming. And I encouraged them to put dependencies in the program manager's schedule so that you could track when a piece of hardware was needed by software, and if the hardware slipped, they could see software was going to slip as a result, instead of the program manager just beating on the software engineer, why aren't you done yet? Why are you late? And they did it, and as a result, they had a much stronger voice in the whole development process. The last thing is my favorite thing about flight software, all the concurrency and the distributed architectures. I think it makes it fun to develop, and it also makes it more complicated. Now, I told you I've been working in the area of ground software recently. It doesn't have these challenges, and so I assumed that it would be easier to do. Wrong. I've seen ground systems that have 10 different languages. They might have C, C++, Java, some old Fortran hanging around. They'll use Python, Perl, all sorts of scripting languages. And that's all software. And then they have all those users. And frequently users don't know what they want until they see it. So the ground software engineers are left with the old problem of bring me a rock. Oops, not the right rock. Got to go back and build another one. So ground software is really messy. My conclusion is that even though flight software is hard, it's nice and clean. You guys know things like just use one language. If I haven't done it before, it's going to take me a little longer. I need to define interfaces first. So I really like flight software. As a matter of fact, the project I'm working on now, they asked me if I'd start working on the ground system too, and I'm like, no, I like the flight. It's much cleaner. Why is it difficult to manage? Well, for some of the same reasons that it's difficult to develop. Can't see it. I can't tell you how many times I had program managers call me and say, you guys are still doing requirements? Why do you need to do that? Why aren't you writing any code? And they really didn't appreciate the need to think about what you were going to do before you did it. You have to, as a manager, be aware of all the dependencies that are going to impact the flight software so that you can help your team make sure that the program manager is aware of those dependencies so that if the hardware is running late, you can work with the program manager to correct the situation. I found that it's very helpful as a manager to be able to talk with the hardware engineers, understand how they're developing their hardware and specifying it, and then look at their schedules and see if they could really do all that work in the amount of time they had allotted, or if they were going to be late. It isn't clear when flight software is done, and this really applies to pretty much all software. You know, I used to resent it when people would say to me, there's always going to be a bug in your code. You can't find them all. And I guess after all these years, I'm starting to believe it. There's always a bug somewhere. There's something you won't find. So how much testing is enough? And what level of testing is enough? And then there's all kinds of testing you can do. You know, you can test to requirements, and that proves that maybe the software works and does a very specific limited function. But does it do its whole job? Does it perform as it should when it's in operational use? Those kinds of tests are harder to develop and require frequently some sort of scenario, maybe a day in the life, or a stressing scenario, or a scenario where you inject faults. This one might be a little controversial. You guys are perfectionists. You want to do the best possible job, and you do not want to compromise. I remember I said to one of my flight software engineers once, perfect is the enemy of good enough. She was highly insulted. What do you mean? I don't want to just be good enough. But there is a trade-off. We have to look at all the things that we want to add and figure out whether or not they're going to add value. Because frequently our missions have critical time constraints. We have to launch, or we miss that comet encounter or other event. I really feel for the flight software team. There are frequently competing demands of their time. They have to build the software, but while they're building it, maybe somebody else is off testing it and finding things that might be bugs, and so they have to ask the software engineers to help them analyze those situations, figure out if they're real. And in addition, the flight software engineers typically have to support INT. So you're being pulled in lots of different directions all at once. I've taken that lesson learned, and now when I'm at aerospace as part of mission assurance, I try to make sure that the contractors who are building systems aren't overloading their staff and pulling them in too many different directions. So here are my lessons learned. I'm going to say that P word. A development process does help. Using engineering rigor helps. Now, does that mean that you have to define every requirement to the nth degree and then design the software down to the lowest level, cast it all in concrete and never change it? No. But I do believe in doing your best effort to get the requirements defined and have them as solid as possible, and then controlling changes to them. That will allow you to control the development environment. The second part of that is I am a strong proponent of designing your software before you go off and code it. I've fought that battle a number of times, and every time I've forced people to design it first, they've come back and thanked me later. When I left APL, one of my flight software engineers came up to me and said, "Robyn, don't ever stop demanding that people design their software first. I didn't believe it when you made me do it, but it works." Now, on the other hand, be careful, because software process can become an end in itself. And one of the things that really scares me as a manager is that I see people relying on processes completely and not thinking about the what-if scenarios. So processes are not sufficient in and of themselves. We still need bright people with good experience who can train other people and be thinking about the what-ifs. What could go wrong? The processes won't find all of that. In addition, more isn't always better. Sometimes you can sign up for an additional process and it doesn't really add value, but it takes time and it takes you away from doing the main job. I like the KISS principle, keep it simple. Elegant designs. How many of you have ever seen the early Kernighan and Ritchie C books? Yeah, remember those lines of code that they would embed 8 statements in one line of code, and you'd be trying to figure that out. And back in the day, we thought that was pretty cool. Well, it isn't really. It makes it much more hard to maintain and understand and test. So avoid those kinds of things. What's cool today may not be so cool tomorrow. I do believe, I'm going to use another example. I had this one program manager who was a real curmudgeon. He was just grouchy all the time, and he didn't like software. And he was always talking about, I want to have a belly button to push. So, it was the image of the Pillsbury Doughboy. If your software's late, he's going to come up and poke you. I do believe in having that belly button to push. I found that if you assign ownership of pieces of the software to individuals, because you're all perfectionists, that has a real advantage. It means that you're going to work very hard to make sure that software is reliable and of the highest quality possible. And it'll be well tested. You'll take a lot of pride in your software. Earlier, I loved the presentation where he talked about peer coding. That was so neat. And I think it makes the point that peer reviews do find errors. Walkthroughs find errors. Recently, on a program, the contractor was conducting code reviews. And their code reviews consisted of running the units through automated test tools. They said they were doing visual inspection of the code, but they weren't. And so I took the code and I handed it off to a software expert, and in 2 weeks, he found serious bugs in the code that had not been found by the automated test tools, and clearly nobody else had really looked at the code. There were bugs, I mean blatant bugs. And I'm not even going to, some of them are just ridiculous. I'm not going to talk about that.
You don't have to mention them, but some of them were really stupid programs.
That's right. Alan's aware of them. They were really unbelievably stupid. System engineers do add value to code reviews. I remember one system I worked on, we had a system engineer who used to brag, I never wrote a line of code in my life. And so we had this really hairy bug that we couldn't find. It had to do with angle measurements, and when you crossed 180 degrees, it went from pi over 2 to minus pi over 2, and so there was this coding bug in there that didn't take into account that switch. And the system engineer, who had never written a line of code in his life, found the bug. So I started to include them in code reviews, and they really did help. I think the next one's a no-brainer. Even if you're just one person writing code on a program, having standards that you're using, coding standards, conventions that you're using, is going to help you in the long run. I don't know, I'm looking forward to your presentation on autonomy, because I've been away from it for a while, and I don't know what people are using now, but not so long ago, rule-based systems in autonomy were owned by system engineering, and they sometimes don't use the same kind of rigor that flight software engineers use. And so the autonomy rules may not have been tested as well. One of the things that I worked very hard to change was to get flight software to own that. And I think it really helped us in the end. I have found that if you do define your software interfaces, even within the code, up front, that it improves integration. I worked on a program once, it was a multinational program, and some of the folks had difficulty with English. We defined design diagrams, though, and we defined our software interfaces and captured those in code and put them under configuration management. And then they went off and they implemented their pieces, components of the code. And when we brought it together and did the integration went very quickly, and it worked, the software worked extremely well. First try. It was amazing. That should be expedite, not expedites. Full integration will go easier if you do some early interface testing. So if you can get hardware and write the software to test it, to exercise it rather, if you can do that early, that will help with integration later. Okay, for managers, you have to use a variety of tools. To be honest with you, when I manage programs, my favorite tools are just to be able to look at the schedule and see where we are, to look at the DR reports, and typically DRs are on a pretty steep slope, and then you hit a knee in the curve and things start to level out, and that's when you know you're really going to be done soon. The other tool that I use is staffing plans. I like to know who's coming onto the program when and when they're leaving, and make sure that you have enough people. With those three tools, I had a great deal of success making sure that all of our software, flight software ground, was delivered on time and within budget, and it worked. That was the most important piece. Not so crazy. Oh, I'm not so. Maybe I shouldn't say this, but I will. I'm not crazy about earned value. I find that establishing cost account managers reduces the feedback and the detailed knowledge that the program manager has. And so then things slip a little bit, and it adds an incredible amount of overhead to have all those cost account managers. So I'm just not sure the value's there. The data typically comes out late, so it's like, you know you're in trouble after you're in trouble. So I'm not crazy about it, but that's just my opinion. I am a believer in schedules. My first job out of college is with my bachelor's. I worked on this project, and the program manager created this beautiful schedule with all the colors of the rainbow. I kid you not. He took a ruler and colored pencils and drew this detailed schedule out. And I thought, oh my God, I'll never do that. Guess who I've turned into? I don't use pencils anymore. I use Microsoft Project. But I found myself doing it one day, and I thought, oh my God, I've become him. It is important to figure out what you're going to do and then try to follow the plan. You may change the plan, and it shouldn't be cast in concrete. You should be allowed to change it, but you have to have a plan going into it. Otherwise, when things start to go wrong, you won't have an idea of why, and you won't know how to correct it. Make sure, like I said earlier, that you track dependencies on other subsystems, be it hardware or ground software, whatever. Have those dependencies in your schedule, and then it will be highly visible when a delay in some other subsystem causes a delay in the flight software. And then just assume problems are going to happen. You know, nothing's ever going to go perfectly, and you're just going to have to adapt and adjust. Having a well-defined scope is critical. You have to know what you're building and how much you're going to build. Late changes to scope in the form of requirements changes will have an impact, and it'll result in your software being late. It may introduce complexity to your software because of late changes. So as a manager, you want to avoid that. I think it's really important, especially with mission-critical flight software, to identify and mitigate risk. So when I was trying to figure out what I was going to say to you today, somebody said, oh, you should talk about the use of cloud computing in flight software. What? I thought that was the craziest thing I ever heard. But yeah, I'm thinking that violates my rule of new, untested technologies. I'm not even sure how you would do it in a hardware, the environment of a spacecraft. Yeah, I believe in limiting the use of new and unfamiliar technologies. That doesn't mean you can't ever change things. It just means that you look at it carefully and choose wisely. Don't throw out everything and start all new with new languages or operating systems or design methods. You'll get in trouble. I've been around long enough that I remember the transition from structured design to object-oriented design. And it was like, I remember the first time I heard about object-oriented design, I felt like somebody turned me on my head. And thought, what are these objects? How do you figure that out? It really seemed foreign at the time. People, though, were excited about it, and they wanted to adopt it, and they wanted to use C++ and object-oriented design. But you know what happens your first time out when you use new methods and new technologies? It takes longer. And so just be careful about adopting new methods or technologies. I think it's really important to have a diverse team, to have experienced people with lots of battle wounds, but also have some less experienced people who might have new, innovative approaches to things, who can be mentored by the experienced people and learn from them. I'm a big believer in analyzing defect metrics. For example, I was looking at some defect metrics yesterday, and the system that's under test is currently in integration and test, and they found very few defects leading up to that phase, and I'm thinking, they're not that good. They're in trouble. They're not really testing. Their unit tests probably haven't been as effective as they should be, and their software integration tests probably aren't effective. You can learn a lot by looking at defects, understanding where the defect was injected. Was it a requirements error? Was it a design error? Was it a coding bug? And also understanding, the complexity of the defect. I believe in managing by walking around. Sometimes I will walk into somebody's office and just plop myself down and ask about their kids and latest vacation. And then they start to tell me about what they're working on and where the hard spots are. And then we can work together to fix it. I think that's really important. You can't just rely on the statistics that you get from things like earned value. And then we always talk about lessons learned. And I know it's become sort of a joke about lessons noted, but it would really be nice if we use them. So when you learn a lesson or when you observe a lesson, try to use it going forward. I don't think there's a silver bullet. We're going to come out with new technologies, new design methods all the time. I was in a meeting yesterday where we were talking about platform as a service and the different layers. And I thought, that sounds an awful lot like batch processing from the early 80s. All of these new things that people come out with are pretty much similar to things that we've tried before, and not one of them is going to eliminate all issues. Doesn't mean that we shouldn't try to improve things. I just don't believe there's a silver bullet. And then I really believe in common sense. I get scared when people rely completely on processes and stop thinking. You really need to have intelligent people looking at issues and trying to figure out where the hard spots are going to be. I'm a believer in strong engineering discipline. That doesn't mean rigid. It just means that you think about what you're going to do before you do it. Appropriate level of processes. It sounds to me like the guys working on the CubeSats are doing a great job of scaling back the formality of the process, but keeping the engineering rigor of having this continual peer review while they're coding. I just love that. In the end, you'll get more reliable, robust, and correct flight software. So that's all I wanted to tell you. Thanks.
Hello. I wanted to thank Robyn because I'm from APL. I'm from her mafia that she created. And she doesn't know me. I mean, this is the first time we are meeting. And I joined after she left, actually. So really, there is a legacy of Robyn in our group, and we have a really good process. People were jealous to know that I was coming here. Thank you very much.
You're welcome.
Anybody has a question?
Hi, Robyn.
Hi.
I assume you're familiar with CMMI, and you've been talking about process and KISS. Do you have an opinion on CMMI? Have you gone through that?
We have. At APL, we were CMMI level 3, and I have subsequently, since being at Aerospace, worked with organizations who, I guess I should be over here, who are level 5 or level 3. The issue with CMMI that I see is that the assessors come in and they assess a program, and then they apply the rating to the whole organization. And sometimes, we're not fools. We're going to put our best program forward, right? And they're going to pass with flying colors. But that doesn't mean the whole organization has adopted those processes. So CMMI in itself isn't, I don't think, sufficient. AS 9100, though, on the other hand, the thing I liked about it was that they want you to train your people in the processes. And so if you have the adequate training and then assess whether the training occurred, that seems like it will result in a more consistent application of processes.
Thank you.
You're welcome.
Hi, this is just a comment. There's a theorem from cybernetics called Kreitmann's conjecture that says that in the face of arbitrary disturbances, you can control for process, or you can control for outcome, but not both at the same time. The problem is that it's so much easier to control for process.
Yeah, that's true. Anybody else? When I was at APL, I was responsible for defining their software development process for all the space missions. And so I don't want people to think I don't believe in it. It's just that sometimes people take it to an extreme and add more and more and more, thinking it's going to result in higher quality software. And what ends up happening is that it just takes more time.
Yeah, I've seen the same thing. I had a comment. This is just kind of a plug for my talk coming up, which is at 3 o'clock. Just trying to get more people to stay for that. But your comments on the instruments, changing requirements of instruments, and also the idea of making a design before you code. Well, those are the talk I have is Laddie and how we did the interfaces to the 4 instruments that were on board, and how we dealt with that and lessons learned. So it's related to this. I thought I'd just tag on that. Thanks.
Oh, good. I was looking forward to that one.
Thank you. So with regards with some of the difficulty of managing software due to being invisible, how do you prefer to get status on the design, especially in an area where you can't necessarily see the direct code? What kind of reporting do you expect from your product line developers, and how do you expect to have that passed up to you at a management level that it actually makes sense but doesn't devour your entire weekend trying to read through everything?
So what I would do, I confess I added some overhead to my product line leads. I would meet with them periodically at the start of the mission, say prior to PDR, and maybe even a little further. I would meet with them once a month, and we would talk about what issues they had encountered, where they needed my help, and they knew that I was genuinely there to help them. I wanted to clear out all the roadblocks and obstacles and get them moving forward. So they would tell me things. But we would basically look at their schedule and talk through their status. The frequency would then increase to twice a month, and then eventually once a week. And the meetings would last an hour. We would keep them to the point, but they didn't have to prepare any new information. They just had to show me their schedule and talk about what issues they were encountering. That worked really well for me and my teams. Now, we were working on medium-sized missions, not like the huge missions that JPL does. More, 15 to 25 flight software engineers total. And then the ground system was, say 10. So that works well in that environment. As the number of people goes up, that's harder to do and harder to be aware of. As far as the designs go, we did hold peer reviews on all of the software. Peer reviewed those designs, and we wrote up action items out of those designs. And so I would be aware of how many action items came out of the review, whether or not they were closed. And you could track that sort of thing to make sure that the designs had been peer-reviewed adequately. And what people would then do along the way, because, you know, frequently you design software, you create these beautiful diagrams, but then you end up changing it when you start coding. That's just reality. And so how do you keep track of those design changes? Well, what people would do is actually print the diagrams and red mark them, like redlining a hardware design, and have that around, so then we would have as-built, we could create as-built documentation easily. You're welcome.
Any other questions? No? Thank you. Thank you, Robyn.
You're welcome.